Hi everyone, let's take a look at the following function. Y equals to e to the power of x times x to the power of 4 times, in brackets, 5x minus 6 all over 2 minus x quantity cube. We're looking for dy by dx, the derivative of y with respect to x. Now, a couple of things you want to think about. Number one, you could apply the product rule, the quotient rule, but this is not the optimal way. So again, would it work? Yes, it does work. Product rule, quotient rule in combination, but this is suboptimal. So the optimal way is to ln both sides. Now, before we do that, here's a refresher of some of the basic properties of a logarithmic function. So number one, be mindful that ln of x is really log of base e of x. Number two, ln of ab equals to ln of a plus ln of b. Number three, ln of a divided by b is ln of a minus ln of b. Last but not least, ln and e are opposite operators. So when you think about ln of e to the power of x, this equals to x. Step number one, ln both sides. So just like adding, subtracting, multiplying, dividing, ln is an operator. So what you do to one side, you do to the other side. So on the left-hand side, you can copy ln of y. On the right, you're going to break it apart. So when you apply this concept, again, when you take the ln of a quotient, you can break it apart. So notice on the right-hand side, this is going to be ln of e to the power of x times x to the power of 4 times 5x minus 6, put this in brackets, minus ln of 2 minus x to the power of 3. Now, here's the second step. Ln of y equals to, and again, when you go back to the first idea now, let's use a different color. When you take the ln of ab, you can break it apart as a sum of ln a and ln b. So same thing here. So what happens is ln in brackets e to the x times x to the 4 times in brackets 5x minus 6 is now equal to ln of e to the x plus ln of x to the 4 plus ln of, in brackets, 5x minus 6 minus ln of 2 minus x quantity cube. Now, there's one more idea that will likely to be activated. Let's put it right here. When you think about ln of a to the power of x, the exponent could be brought to the front. So what that means is ln of y equals to x ln e plus 4 ln x plus ln of 5x minus 6 minus 3 ln of 2 minus x. Now, we're ready to take the derivative. And again, we're applying implicit differentiation. So what that means is, again, you're thinking about dy by dx. This, as a sentence, means you want to differentiate x with respect to y. On the left-hand side, when you differentiate ln y, that's going to be 1 over y times dy by dx. On the right, again, if you look at this carefully, first of all, ln of e equals to 1. So again, we wrote down on the side, ln of e to the x is x, and of course, ln of e to the 1 is going to be 1. When you take the derivative of x, that's going to be 1, plus 4 times the derivative of ln x is going to be 1 divided by x, plus when you take the derivative of ln of 5x minus 6 is going to be 1 divided by 5x minus 6 times the derivative of 5x minus 6, which is 5, minus 3, times the derivative of ln of 2 minus x, which is basically 1 divided by 2 minus x times the derivative of 2 minus x, which is negative 1. Now again, dy by dx equals to, you're going to multiply both sides by y. So you bring y to the right, put a big bracket here. We're going to clean up the right-hand side by collecting like terms. 1 plus 4 divided by x plus 5 divided by 5x minus 6 plus 3 divided by 2 minus x. Now, here comes the final step. Express your final answer in terms of x. So, if you go back to the beginning, y was given as e to the power of x times x to the power of 4 times 5x minus 6 divided by 2 minus x to the power of 3 times, in brackets, 1 plus 4 divided by x plus 5 divided by 5x minus 6 plus 3 divided by 2 minus x. I hope this makes sense.